Trig form of complex numbers means we're going to deal with some trigonometry, sine, cosine, tangent, right? But complex numbers, it's been a while since we've seen them, okay? Complex numbers are something in the form of a plus bi, okay? I think it was Jack way back when who asked, hey, are we ever going to have to graph complex numbers? It's been a long time ago, okay? And I said that they don't appear on our normal coordinate plane, okay? So for example, if we had this parabola graphed, okay? This is my vertex. I didn't do a great job. My book is, or my smartboard is not oriented very well. But if this is my vertex, I've moved 2 to the right, right? So x with 2, but what happens with the sign? Minus, because I moved to the right, right? And I'm 2 up. So if this is my equation, y equals x minus 2 squared plus 2, okay? Opening up, vertex is at 0, or is at 2, 2. What happens if I work this out? X minus 2 quantity squared is going to FOIL out to be x squared. Multiply them together and double them. And then square the last. So far so good? Okay, so this is x squared minus 4x plus 6 equals y. Now, we try to figure out if we could factor that in some way or complete the square, right? If we tried to factor it, we'd say, what are factors of 6 that add to become 4? Factors of 6 are 2 and 3 and 6 and 1, right? So there are no integer factors of it. So we could try to complete the square. We're going to do that a whole lot next chapter. Or we could use quadratic formula. Which one do you want to do? Quadratic formula or complete the square?
Complete the square.
Complete the square. All right. Complete the square says isolate. Get this 6 out to the other side. So we have x squared minus 4x equals y minus 6. Now, what are we going to add to that to make it a perfect square trinomial? Positive 4. Half of 4 is 2. 2 squared is 4. So if we add 4, I've got to balance the equation and add 4 to the other side. And we get x minus 2 quantity squared equals negative 2. Okay, we're trying to solve for 0, right? So we're going to eliminate the y and figure out what the 0 is. Now, how do we get rid of squares? Square roots. So if we square root both sides, we get x minus 2 equals plus or minus the square root of negative 2. Is there going to be a real solution here? No, because we can never, ever, ever do two things, right? We can't divide by 0, and we can't take the square root or an even root of a negative number, right? And so this would be 2 plus or minus getting ahead of myself, 2 plus or minus I squared root of 2. Okay? That's why it never crosses the x-axis. There is no place where y is equal to 0 in this particular problem. Does that make sense? Okay? So, when we want to display this, we have to change from our x, y graph, coordinate system, right, to a real and imaginary coordinate system. Okay? So far so good? So, if I wanted to graph this new complex number, 2 plus 3i, on this real imaginary coordinate system, this complex coordinate plane, what do you think I would do? 2 to the right and 3 up. Just like our complex or our x and y coordinate system, we're going to go 2 to the right because it's positive, and 3 up because that is positive. And this is the point 2 plus 3i on the coordinate plane, the complex coordinate plane. So far so good? Okay. where will 5 minus I be? Right, 5, down 1. Okay, where is negative 5i going to be? 0, negative 5. 0, 0 to the right, and negative 5 in the complex direction. The imaginary direction, sorry. Okay, and finally, where will negative 4 be? Yeah, negative 4, 0. Negative 4 on the real part, 0 on the imaginary part. Easy peasy? You're going to have problems just like that. That's simple. Okay? So far, so good? All right, so next, we want to talk about the absolute value of 3 plus 4i, the absolute value of a complex number. Okay? Now, when you hear absolute value, what do you typically think of? Up and down brackets, right? Okay, so if I want the absolute value of negative 3, what does that mean? Becomes 3. Why is it 3? What does it physically mean? Or how was it defined to you originally?
That there are, I don't know.
Well, let's go back to the number line. Why is the absolute value of negative 3 equal to 3?
Is this the same distance from 0?
Yes, it's the distance from 0. We never talk about distance as being negative, right? So it has a distance of 3 from 0. So far, so good? So what was the absolute value of 5 then? 5, because it's 5 away from 0 on the number line, right? Okay, so what do you think the absolute value of 3 plus 4i is now going to represent?
Probably the distance from the origin.
Good, we're now in 2 dimensions, aren't we? So instead of being on a number line and wanting to know how many steps away it is from a point, 0, we want to know how far away it is from the origin. Okay, so what is our answer going to be here? How are we going to find it?
Well, we're going to make a triangle.
Yeah, make a triangle. We've got a right triangle here.
3, 4, 5 triangle.
It's a 3, 4, 5 triangle. Okay, so the absolute value of a complex number is going to be the line segment, length of the line segment from the origin to the point. And we simply use Pythagorean theorem, don't we? Okay. So let's find the absolute value of negative 5 plus 2i. What'd you get? Square root of 29? Okay, everybody get the square root of 29? Okay. Because we're taking the square root of 25 plus 4, and we square negative 5 and square a 2. Okay. All right, so now we're ready to talk about the trigonometric form of a complex number. Okay. By the way, what did that did it remind you of anything? The absolute value of a complex number? R, right? Back when we were talking about our unit circle, if it wasn't a unit circle because its radius was more than 1, right, we had to find R. What else did we do recently? Yeah, those vectors, right? What was this the same as, or same process as? The length of that, or the magnitude of a vector, right? Okay, so is it a big surprise that the magnitude of vector v, that they use double absolute value symbols? Not necessarily, right? You should make those connections in your brain, okay? So nothing spectacular there. So we want to talk about the trig form of a complex number. So how do we determine theta if we have a plus bi, where a is your horizontal movement and b is your vertical movement, right, on the vertical imaginary portion of the plane? How are we going to find theta? If we know a and b, what will we do to find theta? Someone said it. Tangent. The tangent of theta will be equal to opposite over adjacent, right? So if we want to get the theta by itself, we have to take the inverse tangent of b over a. We've been doing that ad nauseum, right? Okay. And we wanted to find our direction angle with a vector. All right. How are a, theta, and r related to each other? How are these guys related? Cosine? Mm-hmm. Adjacent over hypotenuse, right? Cosine of theta equals a over r. So if I wanted to get the a all by itself, what would I do? R cosine theta. Okay. How are b, theta, and r related to each other? Sine. So sine of theta is b over r. So b is the same thing as r sine theta. Does that look familiar? Mm-hmm. Okay. So if I want to write the trig form of a complex number, instead of a plus bi, that's the standard form, my a now stands for, colors. My a now stands for r cosine theta. My b stands for r sine theta. And I need an I here, don't I? And a lot of times we like to put the I in front. So r cosine theta plus I sine theta. I r sine theta. Okay, what do they have in common? R. So if we factor that out, our trig form of our complex number is r times cosine of theta plus I sine theta. So far, so good? Okay. This is going to help us do some heavy lifting of mathematics easily. Okay, so far so good? All right. So, given the complex number, -5 plus 6i, let's write this in trig form. The trig form of the complex number. So we got the standard form, we want to go to trig form. So what's the first thing you're going to do? Yeah, sketch it out. So -5 plus 6i means I've gone 5 to the left, right? 6 up. That's my point. So let's find the absolute value of it to find our r. What are we going to get? And 36 is 61. No perfect squares in there, so square root of 61 is our r. Now what do we need? Theta. How are we going to find theta? Tangent. So the tangent of theta is what over what? E over a. So now here's what I'm going to suggest. Drop the negative. Okay? Just find 6 over 5. Okay? Because your calculator wants to lie to you. Where's the inverse tangent defined? Only in 2 quadrants, right? First and fourth. So it's going to give you a fourth quadrant answer since it was negative. So just use the 6 and the 5 and find the inverse tangent of that. What do we get?
50.19 degrees.
So 50.2 close enough for everybody? Okay, that's this theta. Yes, sir.
So why would you use the tangent on?
Okay, so we have to use the tangent because the 2 parts we know that we were given are the opposite and the adjacent.
Yeah.
Okay, so we're going to say the inverse tangent of theta, of the tangent of theta, is going to be equal to the inverse tangent of 6 over 5. And the reason we're not using the negative is because the inverse tangent is only defined in 2 places, the first quadrant and the fourth quadrant. Make sense?
So you still use the inverse tangent on it?
Yeah, we still use the inverse tangent, but instead of a 6 over -5, just use 6 over 5. Okay, plain old 6 over 5. And that's going to give you your reference angle. Okay, that reference angle is 50.2. Okay, but how far actually are we from the positive x-axis, our real theta? 129.8. Why is it 129.8? Yeah, we're just that much short of 180, aren't we? Okay, we didn't make it all the way to the negative real axis, right? We're 50.2 degrees short of 180. Okay, so whenever you're doing these problems and they put you in the first or the second or the third quadrant, you want to use the positive values for your side legs and then figure out where you're at. Okay, so if you're in the first quadrant, no problem. This is your theta. Okay, but if you're in the second quadrant, then whatever theta you get using those positive values is going to be 180 minus theta. Okay, and if you're in the third quadrant, what's going to happen? Yeah, well, 180 plus that theta. and we're in the fourth quadrant, then what happens? Does that make sense? Okay, so your calculator's going to try to lie to you, right? It's going to try to push you into this fourth quadrant if it's negative. And we weren't in the fourth quadrant. So we have to find the true angle there. Make sense? Okay. So we've got all the parts we need. We had to find r, and we had to find theta. Okay, so let's rewrite this now in trig form. So what's the trig form look like? Square root of 61, or r, right, times cosine 129.8 plus I sine 129.8. This is not our angle, right? This is our theta prime. Okay, our real angle is this 129.8 degree angle. Make sense? Okay. What do you think is going to happen if I take this square root of 61 times the cosine of 129.8?
Here.
Mm-hmm.
Or,
Try it.
negative.
Yeah, we're going to get something really, really close to -5, right? With some rounding errors, right? Because we stopped at one decimal point. And what happens if we take the square root of 61 times sine of 129.8? We'll get our 6. And that's the way you check to make sure you get it right. Okay, make sense? Questions on this one? Yes, sir.
So is this trig form, like z equals?
Yep, this is the trig form. So we've got a number out in front, right? Our scalar, our absolute value of that trig,
Yeah.
of that complex number. And then we've got the trig portions of it, the cosine and the sine with an angle. So that is the trig form.
So like, I kind of got lost like with all like the graphs and all that.
Okay.
What was that trying to show?
Okay, this is just to show you that, so we happen to be in quadrant, what would be quadrant 2 of our regular plane, right?
Yeah.
Of our coordinate plane. And because of this, when we drop the negatives so the calculator doesn't lie to us, right, or doesn't tell us a fib, we found out it was 50.2, but because we're this far in, it's 180 minus 50.2, okay? Had we been over here, no big deal, you use the number that comes from the calculator, okay? Had we been here, that's what we had to do, the 180 minus theta. But had we been in the third quadrant, then we'd have to do 180 plus that theta to get all the way to this, okay? And then in the fourth quadrant, we just take 360 minus our theta. So we have to be able to find that reference angle, okay? Or use that reference angle to find our true angle.
And then that's all just to get like cosine.
Exactly. That's to figure out the true angle. This is the angle we needed to use. Okay? Other questions on this one? Okay, so what if I give you the trig form of a complex number, and I ask you to find it in standard form?
Just multiply 3 times cosine.
Yeah, multiply 3 by the cosine of 315. If we know this, because it's one of our friendly angles that we know, we're going to leave it in the square root form. What is the cosine of 315? Root 2 over 2. And what is the sine of 315? Negative square root of 2 over 2. The sine is negative in that quadrant. And of course, we could take 3 times the square root of 2 over 2 to figure out what that will be as a decimal. But that is the trig form of our complex number. We like to put the I in front of the radical as opposed to the back, so it doesn't sneak inside with the radical accidentally. Okay, questions in this one? Okay, forward, backward. All right, so here's the product quotient rule for trig forms of complex numbers. If you want to multiply two complex numbers that are in a trigonometric form, you multiply the r's and you add the thetas. Multiply the r's, add the thetas. If you want to divide two complex numbers in trigonometric form, you divide the r's and you subtract the thetas. And your angle has to be between 0 and 360, 1 revolution. Anything beyond that, you've got to move it back. So if I have two complex numbers and I'm asked to multiply them, I multiply the r's, multiply the absolute values of them, right? And I add the thetas.
So what do you do if your angle is over 360?
If it's over 360, let's say it's 400, okay? Then we just subtract 360 off of it and get 40. Okay? Take a revolution or two, or however many you do off of it. If we're dividing, we simply divide the radius by the radius and then subtract the thetas. What's difficult but it's going to make life easy? All right, let's see it in action. All right, so here we go. So, I want to take 4 cis 120 times 6 cis 315. What the heck is cis? I think CIS stands for. Well, we were just been talking about these, right? Z was 4 times the cosine of 120 plus I sine 120. Abbreviation, right? Isn't that a lot less writing than what I just wrote? Okay, I'm taking that times 6 times the cosine of 315 plus I sine 315. Okay, so what did we just say that we could do if we're multiplying two complex numbers? Multiply the r's, 4 times 6, 24. And then what do we do with our thetas? Add them, so 315 plus 120. For 435, right? What was the disclaimer that we had? Theta has to be difference between 0 and 360. So if we take a revolution off, we subtract 360 from it, what do we get?
And
75 degrees. So this is 24 cosine 75 plus I sine 75. Make sense? Not too bad, right? Let's do a division problem. Fifteen says 240 divided by 3 says 135. Divide our r's and subtract our thetas. 240 minus 135? 105, right? Easy peasy? Okay. It's going to make life easier tomorrow, knowing how to do these. Okay, we'll spend one more day on this tomorrow. Questions on this one? All right, assignment.